All righty. Everyone, welcome to Data Engineers Lunch number 58. Today we have a guest speaker from InfinyOn, Sehyo Chang, and he'll be giving a talk on an introduction to Fluvio OSS as well as InfinyOn's cloud data streaming platform. You can find out more at InfinyOn.com. You can also find them on Twitter and all social media. Co-organizers for this event are Rahul and myself. We are looking for guest speakers or sponsors. So if you're interested in giving a talk either here at Data Engineers Lunch or our sister lunch, Cassandra.Link, feel free to reach out to me. My email is listed below. Also, if you're interested in being a sponsor, you can always reach out to me as well. We are a part of Data Community DC. Data Community DC believes in building an inclusive culture. So no matter your race, gender, sexual orientation, everyone is welcome. And we expect the respect to be given to all. Data Community DC is built up of a bunch of different organizations. You can find out more. Our specific event today is held under the umbrella of Data Wranglers DC, but you can find out all the other organizations that fall under the umbrella, and you can find out about all the other different events that are held by Data Community DC at datacommunitydc.org. So what do we cover here at Data Engineers Lunch? We cover everything that is data wrangling, ETL, data cleansing. That's essentially ingress and egress of data, as well as transformations that happen along the way. So data that comes in unprocessed, processing it, and then putting it to where it can be used by data analysts, data scientists, business analysts, etc. So anything that is data engineering or plays well with data engineering, we do cover here at Data Engineers Lunch. So this is a time, if anyone's new, please say hello in the Zoom chat or YouTube chat. We are a community, so feel free to say hi and hello and meet others. Group rules, if you have a question, please do ask it. However, please be polite and courteous to others. This is meant to be, again, a community, so if you do have any questions or comments, feel free to drop them in the chat. But more importantly, please respect the speaker's preferences. Depending on the speaker, they may prefer questions in the chat, or they may prefer you just to speak up when you have something to ask. But again, our guest speaker for today will address that when he takes over. And again, this is a community, so please do share what you know with us. So the more you know, the more everyone will know. Here at Anant, we design, build, and manage global real-time data analytics platforms surrounding Cassandra, Spark, and Kafka. So data engineering is a way of life for us. DataStax is a partner and a sponsor. GW University also helps us provide in-venue space when we have in-person events. We have some institutional and program sponsors. Any announcements, anyone have any jobs to offer or are looking for jobs, any meetups, hackathons, conferences, classes that they would like to promote, feel free to drop links in the chat below, either on YouTube or Zoom. If you drop them in the Zoom chat, we'll also get them sent over to the YouTube chat as well. A currently ongoing event is DataStax Astra's Buildathon. It's 3 months of challenges, essentially one challenge per month. They've already started for the first month. If it's too late to join for the first month, you can always join for month 2 and month 3. Essentially, the top 3 winners for each round will qualify to present their project ideas on demo day at the end of May. But for each monthly challenge, there are winners so you can win money, swag, other prizes per month, but then also if you end up being the top 3 winner, part of the top 3 winners for each round, you can win the prizes for the demo day prizes as well. So if you are interested, you can check out the link. I'll drop this in the Zoom chat as well as the YouTube chat once we get to handover. We are hiring full-time or part-time positions, whether that be data platform operators, engineers, or architects. You can find out more at careers.anant.us. Some upcoming events, again, our sister lunches happen on Thursdays at the same time. We are looking at having a more variable time slot for Data Engineers Lunch as well as Cassandra Lunch. So that way we can cater to a more worldwide audience. But again, because these events happen live and are streamed directly to our YouTube channel, if you're not able to attend in person, you can always catch up on our YouTube channel, youtube.com/AnantCorp. And Data Engineers Lunches, again, happen every Monday at noon Eastern. And with that, we can hand it over to our guest speaker for today, Sehyo.
Hello, it's nice meeting you all. And let me share my screen. right. Right. Thank you. Sehyo Chang. I'm a CTO of InfinyOn and creator of Fluvio project. I'm very excited to give introduction to Fluvio, which is the open source data streaming platform. And I'll prefer to get a question to verbally. So, but please feel to interrupt me at any time. Okay. So, what is Fluvio? Fluvio is the engine for real-time economy. Today, we live in a hyper-connected society. Every day, more and more of our world is becoming digitized. Not too long ago, we used to order item through the mail or use the phone for making a restaurant reservation. Today, we buy stuff from Amazon through and order from food delivery company like DoorDash or Uber Eats. These types of instant gratification raise expectation from customers. The apps need to transform customer requests quickly to downstream process and automation. That requires a data stack with a very low latency, with reliability and scalability. Lastly, it need to be flexible since each application requires a customization for each business domain. Building a real-time data stack with this kind of capability is very difficult. The goal for Fluvio project is to make this one easy as possible. Okay, so now let's look at this we call typical model data stack. I'm sure many of you are kind of very familiar with, and consists of user suspects like each five-train transformation to the DBT, and to the bunch of data warehouses and data visualization tool. All the user suspect. Typically, they use a batch ETL where it takes a lot of minutes or even hours to send data from one end, from source to typically to a destination like Snowflake or other applications. Adding use processing stage takes more time and cause more delays. Of course, if there are any errors or problems in the stages, it just adds more uncertainty to the overall pipeline. It's no wonder it takes tremendous amount of time and resources to build a real-time data stack. This so-called modern data stack is designed to operate data at rest and not in motion. Okay, so I believe the core of the problem is just a lack of abstraction to the data in motion. Without a solid conceptualization, managing data in motion becomes art rather than a science. And if you put this tool on top of the shaky foundation, it becomes brittle and difficult to understand. The only abstraction that many of these tools will probably agree on with the SQL. However, the SQL was invented in the 1970s in the mainframe area. The relational model that makes sense for financial transaction, focus on reducing storage costs, improving query efficiency. It also makes it very hard to integrate with the application, since most of the developers, just like me, wants API. So how do we solve this? Well, it turns out that there's been a lot of progress in software design in the last 50 years since SQL was invented. One of the most concept is concept as a streaming, which is becoming a mainstream API in many languages. In the simplest term, stream is just a never-ending data sequence. The power of the stream is that it can be composed like a flow of the water that going down the streams. And if you want to make a more complicated, more data, you just compose one of them another. And with the notion of sequencing, you can represent time and history, and this is enough for building a data stack for data in motion. And on a code in the snippet just shows the example in a Python that you can, using that, you can compose pretty much a very complex transformation. Okay, so then let's give an overview of Fluvio. Fluvio is an intelligent data stream platform. It's open source with Apache 2 license. And one of the most interesting part of this is that it's a stream as a first-class citizen. And the goal of Fluvio projects is to make easy to create a real-time as providing scalable real-time data infrastructure. Okay. So let's go with these properties in one at a time. Okay. The first, the Fluvio is built on a language called Rust. I'm not sure how many of you are familiar with the Rust. When we started Fluvio project, we decided to use Rust, which was recently reached 1.0. So why not Java, which is used by many existing mainframe streaming platforms such as Kafka and Flink? And why not C++? The key reason is that we are not satisfied with the status quo. We want to make a streaming process used by everyone, not just resource-rich projects and organization. And we want to put a stream processing into the smallest device as possible. And that cannot be done with a language like a Java. And this is not easily accomplished with a language like a C++, because we don't think that's a safe language. There are too many memory leaks and potential segfaults. Study by Microsoft shows that memory leaks cause very majority of CVEs and other vulnerability. So Rust is the only language that brings high performance with the productivity of high-level languages. So the following graph shows the performance advantage of Rust compared with the other languages. The tests actually utilize the web server with a lot of heavy I/O. And so it's sort of corresponding to streaming processing benchmark. As you can see, Rust has a similar performance characteristic of C and C++, but with a very low latency. And this is due to mainly with the lack of garbage collection. And if you put a lot of high latency requirements, such as P99.9%, the more challenges work with the garbage collector language. And it actually is pretty much impossible to get a very, very low latency like that. Of course, since Rust is a safe language, it is more reliable and less prone to random crash or security vulnerabilities. On the right, table shows how efficient Rust is compared with Java. This is the Fluvio SPU takes 1/5 of memory compared to Kafka and with a significant latency. Now the Fluvio is still in beta and we haven't fully optimized the entire stack yet. So the more the memory latency figures and the memory will be a further reduction. Another unique property of Fluvio is that it puts stream as a first-class citizen. Rust Stream API is a standard part of async Rust, allowing building highly scalable I/O bounded application with a minimum latency. Building on top of the Rust streams, we can build a different stream abstraction on top of it. For example, a durable stream will cover in a subsequent section, which allow you to store events with the time and history property. Since the Rust stream uses a minimum abstraction, you can easily map to a different language such as Python and Java. Next, Fluvio is designed as a cloud-native application from the ground up. First, it natively supports Kubernetes out of the box. It uses a declarative management to scale up and down internal process. It is made of loosely coupled components that use eventual consistency to synchronize data from one streaming process unit to another streaming process unit. There are two main components in Fluvio. The first is the streaming controller, which handles all the metadata management, and it distributes the metadata from the metadata database to the individual SPU. And is also responsible for orchestrating different components. The streaming process unit, or SPUs, where the actually stream is stored and managed. The unique part of the Fluvio is that it decouples the control plane from the data plane. This is based on the lesson learned in building a very complex infrastructure like SDN and the typical cloud infrastructure. Okay. At heart, the Fluvio uses immutable data stream to decouple producer and consumers. Using a similar concept like a Kafka and processor, Fluvio stores the data records in an immutable storage. There can be a multiple producer, but only one at a time. The consumer can be unlimited and independent of each other. Each consumer can read from any position of the streaming and doesn't disturb the other consumer. All the consumers will eventually consume new data written by producer as soon as they are written. Now, with the SmartModule, the customer can perform the transformation on the stream before the consumer receives them. That will be covered in the subsequent SmartModule sections. Okay. With the durable streams, the key concern is that they must lose the data. This is accomplished by replicating durable streams across SPUs. Some streams, such as a financial transaction, may require high degree of replication, but other data, things like machine learning data, are fairly lossy and doesn't need a degree of replication. Durable streaming can be partitioned for scalability. Each partition is independent of stream that can be grouped for abstraction purpose. For example, a stock transaction can be partitioned by stock exchange or table symbols. Now, let's talk about the clients. We want to make it easier to integrate Fluvio with as many applications as possible. This is where the Rust shines. Since it doesn't have a garbage collection, it's easier to integrate with as many languages as possible. So all the language bindings share the same core Rust libraries. So whenever we add new features or fix bugs, that can be propagated to each language binding easily. The client works in all major OSS, and we both support x86 and ARM64 binaries. Our client even works in a browser using a WebAssembly version, and they communicate through the WebSockets. Okay. So this is an example of showing an example code in different language bindings. So on the top left is the Rust version. On the bottom is a Python, and we even have a Java version as well. And every time we add new API, we can push to this language very easily. Okay. So the next is what we call intelligent processing through the SmartModule. Until now, I have shown how Fluvio can store and send stream from source to destination. But part of the stream is that you can perform any arbitrary transformation as demonstrated in Python code before. Using a technology called SmartModule, Fluvio can perform arbitrary inline computation before sending out to the customers. For example, the SmartModule filter can only send the records with a salary greater than 80,000. Note that this transformation or filtering is done in SPU. So it's done in a cluster and not in the client. So if you have a millions of records, you don't have to send all the records to client instead of just sending a few at a time. So saving a lot of network costs and the bandwidth as well. And that becomes very critical when you're running a cloud, where the transmission costs can be very significant. Okay. Now, how is the SmartModule implemented? The Fluvio leverages technology called WebAssembly, which is implemented in the modern browser. If you use Chrome or Safari or Firefox, you will probably have run WebAssembly code. It is a proven technology to run arbitrary code in a secure sandbox. Fluvio uses the same technology, but runs in our SPU and tightly integrated with the stream execution engine. And we are the first one to build a arbitrary streaming semantics in data processing stacks. Okay. So we have so far implemented some typical smart modules. They are filters, maps, and aggregates. And we plan to add more complex streaming primitives, such as windowings and joins. Currently, we support SmartModule using only the Rust languages, but we plan to support different languages like Python and assembly script, which is very similar to JavaScript. Okay. The smart modules are deeply integrated into Fluvio components, into a client, or even a connectors, or even SPU. So we can actually build a very flexible, customized components. In the case of connectors, the smart modules allow connector to transform or reshape the data into design formats into storing the durable streams. There are much use cases that we intend to use smart modules everywhere in the Fluvio to really customize the behavior without having to go and restarting the components or rebuilding. Okay, so that's sort of an overview, and I'm going to try to do the demo. But if you have any questions, please. Anyone has any questions? All right. So let me just do a quick demo. Let me stop.
Don't see any questions in the Zoom chat or the YouTube chat.
Okay, so let me share my. Okay, hope everyone can see my my screen here.
Yep.
Okay, great. So Fluvio is open source, so you can actually download this from our documentation, and we have a fully provide a CLI. So let me show how we can actually install it first here. So just by doing this, they will download it from here and insert to as a binary. And the only requirements for now is that you have a Kubernetes install. In my cases, I've installed Rancher Desktop because I'm running on a Mac, and I can say shows a Fluvio version. So I'm running a version 9.21 using a Redis dev build, and it's running on a Mac. And then the Fluvio actually CLI has a concept called plugins, which will let you extend the CLI by using extension in actually in any language or even a bash scripts. Okay, and so if I do also Kubernetes version, and it's running on the Kubernetes version 1.22. Okay, so I installed the Fluvio, and the next thing I'm going to do is actually I'm going to start the Fluvio cluster. Okay, so what this does is it starts all the Fluvio components. And what it does is that it downloads the Helm, it installs the Helm chart into the Kubernetes. Okay. So if I do, okay, so this actually shows they're running a two-component SC, which is the streaming controller, and SPU, and have a Fluvio cluster. And in our CLI, you can actually, anytime you have if you want to see what's doing, you can just say help. Okay, so what I do is SPU. So I do have SPU list. So actually, this launches the one SPU because I want to make this is a fairly simple cluster just with one SPU. But you can actually create a SPU with a number of like a tree to support the different replicas. Okay, and what we're gonna do is we're gonna create a simple durable stream which core topic. So we are using a similar kind of names to like a kappa to make it easier for transition. So first thing is I should topic create message. Okay, and I do Fluvio topic list. Okay, so it creates the one stream called message and has a one partition, the replicas, and it has a retention time of 7 days. So what that means is that it will store the data for 7 days, and any data older than 7 days will be purged because we don't have, basically we have a finite unlimited of storage. Okay, so next thing I'm gonna do is I'm gonna open up here. Okay, I'm gonna do on the right side. I'm gonna start a consumer. Okay, that outputs the message as the producer write to it. So I'm gonna say produce message. Okay, so let's just add some sample data. So like for fruit, apple. Okay, so as you can see, the data transmission is immediate because we're using a stream technology. There's no polling. There's no no delay. So as soon as because all the messages done handling asynchronous way, so the consumer receive the process immediately. So let's do another here, banana. Okay, and varies, and so on and so forth. Okay, and then here I'm just using this a feature of our consumer that lets you print out, transform this into some formatted messages. So here it shows the offset number, the position 0, and it shows the message apple, banana, and variance, and so forth. And then if I start, okay, so if I start from the end, so I don't see here because it only shows the new messages. So if I say another one, let's say grape, it shows that number 3. Now I can always start from any position, so I can start from the beginning here, and you can see here. So you preserve the history, so you can actually get the customer from any point on the streams. Okay, so now this is not so much interesting. So next I'm going to show you our SmartModule capability. With the SmartModule, you can apply that transformation as I talked about on the slides. So okay, so here is sample code. Let me see if you can see here. That actually what it does is a very simple filter that goes and ignores, only sends the message that contains the A. So if I do the same here, okay, so the first thing I'm going to do is I'm going to upload this filter using a SmartModule. Okay, so I've done that. And when I've done that, it creates this filter called A filter. And it has the size of 456 bytes long, because this is actually a compiled code using a WebAssembly format. But this SmartModule can be written in any language. And what happens is that when I created this SmartModule, it creates this binaries and upload into SPU, and that SPU can be basically deployed anywhere. So now I've done that. Let me go and filter out, apply same the filter here, and as you can see, it actually only shows apple, banana, and grape, and ignore the varies because the varies doesn't have an A. And let's do another one here, and another here, ABC, and it's showing up because content here. But if I do JJJ, it doesn't. Now the important part of this is that the filtering is done at the SPU, not in the client. So if you have millions of data, that all the process is done in SPU, not in the client, and that those transformations can be composed. And we have a lot of different kind of here, some example here. Aggregated, some JSON transformation, and that's described in our website. Okay. So next I'm going to do is to show some more interesting capabilities. So this is a fairly simple example. So what I'm going to do is I'm going to switch over to our cloud platform. So we have a Fluvio Cloud, which actually can let you run this Fluvio cluster in a cloud, which runs in AWS. So with the Fluvio CLI, you can switch it from communicating from one Fluvio cluster to another Fluvio cluster. So currently it's running on my desktop, but I can switch over to cloud. Okay. And here we have a very simple example where we have, let me just share, show. Okay. So we have a connectors called the MQTT, which gets the data from the city of Helsinki. And let me show you the role, and this is running live. So you can do Fluvio consume transit data. Sorry. So that's the data. Okay. So as you can see, this is consuming this is a real life data from Helsinki. It's retrieving all the bus event as the bus is moving through the city of Helsinki. And what it does is it's actually transforming some data from the Helsinki, which is not in, has some other data, and it's filtering out and put it into this JSON format. Okay. And what I'm going to do is I'm going to Yeah. To first demo. And there's a bunch of smart module that does a transformation. I'm going to show the very simple one. Okay. And what the code does is that it takes this code and make into something that more presentable. And as you can see, this is not a trivial code. And what it does is that it extracts the latitude and longitude from the JSON and put that into the presentable format. Okay. And this allows to build a very arbitrary transformation. And let me do with that. Use that code and put that into the format that is useful for the table here. Okay, so you can see, so from the JSON to this tabular format, and you can see the bus here route, and it's heading to different destination, the latitude, longitude, direction, stop ID, and bus information. And you can see this latitude, longitude as real time. And that's basically, there's no delay here. So you can actually do the real-time transformation. Imagine this can be input to mobile apps or website or any kind of application into the downstreams. Okay, so that shows the power of kind of ability to do kind of this kind of complex transformation and make it suited for building a real-time data stack. Okay, so that's general overview. Any questions?
Yeah, I have one. You mentioned like you're using Kafka similar syntax, and you did that with the topics. Is Fluvio intended to be like a direct alternative, or is it something that can be used in conjunction with something like Kafka?
Well, yeah, that's a good question. So, so we do have a lot of common semantics. So it's not a sort of a one-to-one replacement, but we do have a lot of features. So in some projects, that if you don't have a Kafka, or if you want to start from the ground up, I think certainly we can be suitable for that. But we can also work with Kafka as well. Take the data from the Kafka or output to Kafka. So that's one of the things that we're on a roadmap to make it interoperable and working side by side.
Great. And then I guess another question is, I see that like on the GitHub README, it's Fluvio is currently in beta. Do you have like a initial idea of when it would be something that can be used in production in your term roadmap?
Sure. Yeah. So I think so currently it's actually fairly stable. So what is lacking is we're doing a very comprehensive test suite to make sure that we can cover all the things like the replication and have a more reliability and the fine tuning. So we're working with multiple partners, and some of it's in the trial. So we want to iron out as much of Minko as possible. So we're hoping to be able to production in a few months.
Great. One last question for me. Sorry. So I see that obviously you're using JSON data here. Is there necessarily a a data type format restriction, or can you use versatile language or data formats when moving data with Fluvio?
Yeah, so this is we use JSON because it was just easier to visualize, but basically any binary data can be used. So it can be Parquet, it can be any kind of binary or representation. It doesn't really matter.
Cool. And so I guess an extension to that is if you're doing these, as you mentioned, you showed these array modifications to do like kind of quote unquote, or do the early stage transformations ahead of time. Is there a way to say if your data is like Avro serialized or serialized in general to the maybe potentially encrypted or make it smaller and faster? Is it based on the Rust code that you have that, so if as long as Rust is compatible and can read certain types of data, it should be usable?
Yeah, so the example is because our the current SmartModule is based is only can be written in, the example can be written in Rust. So it's out that way, but what we want to do is support that different schema format. So instead of using a Rust, only the Rust as the data format, we want to allow to define the format in schema so we can do translation and enforcement in any of the languages. So that's on the roadmap.
Great, thank you.
I guess that's any more questions. I guess that's.
Nope, I don't see any more questions.
All right. Well, anyway, thanks for listening to the introduction to Fluvio. Like I said, we're in beta, and we want to encourage to try Fluvio, and let's see if it can be used in. Let you guys know, everybody know what you think, and to make an improvement to it.
Great, thank you, Sehyo. Do you have any links potentially? Is the Fluvio roadmap public, or is that internal?
We are trying to build a public roadmap, so we're going to be put out that quite shortly. And
keep an eye out. Give them a like and a follow on social media so you can keep an eye out for those roadmaps, as well as keep an eye out on the GitHub link dropped in the chat, so that way you guys can be informed. This looks like a really cool technology. I'm interested to see how it's going to be used. Maybe once people, if they're not using it privately, once they open source some tools that use the Fluvio framework, that'd be really cool to see. So yeah, I'm interested to see how people can use this in their architectures. But we'll open up the floor one more time to any last questions. If no one has anything, we can go ahead and wrap up. Just give everyone a minute. Okay, doesn't look like any questions. Again, thank you, Sehyo, for joining us. If you guys are interested, definitely check out InfinyOn. Check them out on GitHub and social media. And if you're watching this on YouTube, don't forget to like and subscribe, and we will see you guys next week.